Okay. All right, so heart dissection, this is happening right now. The first thing that I will do is go over the external anatomy. We want to figure out what's the front and what's the back, and so this is the top and this is the bottom. But how are we going to know what's the front and what is the back? There's two ways that you can figure this out. The first way is by feeling, palpating the tissue. And what I know and what you'll know is that the muscles that make up the heart are thicker on the left side, because the left side is responsible for circulating blood throughout the whole body, so it needs to create a lot of force. So as I'm just pushing, I'm going to push on all of the parts on this side and try to find one that is tougher. Now, already this side is thicker, it's the left side of the heart. The other thing that we can know because of external anatomy, the left versus the right side, is that there is a line. So this sulcus that goes diagonal, the one that is going diagonal, is going to tell me that this is the front of the heart. On the back side, and I'll show you guys in a second as well, on the back there's another one that runs just perpendicular to the top. Okay, so perpendicular. The other external features are here, and I'll show again you guys in a second. These floppy parts that look kind of like elephant ears are called auricles. Interestingly enough, the fleshy part of our ear is also called an auricle, and that is the external part of the atria. These are where the atria are. So the right and left atrium are inside of those floppy auricles. Okay. Let's see, what else can we see? We can see some veins, and we'll explore further what all of these different veins and openings are, which are a lot easier to see once we do the actual dissection. So let's check it out. So what I'm going to do is I'm going to make an incision all the way around the heart and kind of flip it. Okay. Okay. Doing it this way. And I'm not going to cut it entirely in half because I still want some of the valves and vessels to be intact. There we go. Maybe that's better. Okay. So I'm sure a lot of you have heard of heart attacks and things like that and how that occurs and why diet is really important for, not getting heart attacks. What happens is all of this fat tissue on our heart, we start to build up more fat tissue. So if you were to look at the heart of someone that is really, really obese, what you would find is that they have a lot of fat all over the heart. And what happens is you can also kind of see, let's see, focus. What you see is there are veins and there are arteries. So coronary arteries running along the heart. So we'll come over here again. So this is an artery. If we get too much fat buildup, what happens is it actually pinches and blocks off the blood flow. So any blood coming from here doesn't bring oxygen to the bottom part of the heart. And that part of the heart stops and it's damaged permanently. It can't be really reversed. And so what happens is sometimes they'll open up these arteries, these veins, and put a stent in, which means it kind of just reopens this pathway. Or what they can do is bypass the blockage altogether, where they'll take an artificial vein or from some other source and they'll attach it and then just kind of plug it in somewhere else. Okay, so like I said, this is the left side, it's much thicker. This is the right side. So if this was in my chest, it would be this way. Kind of right here. It's just about in the middle and then tilted to the side, just slightly. Okay, so let's look at some stuff inside. But looking at the inside, we'll just flop this open, and right away what you can see the difference of is the wall of the muscle. So this is quite thick. It's probably at its thickest maybe almost an inch, and then the right ventricle is pretty thin, maybe a centimeter, half a centimeter, something like that. It's pretty thin. Okay, other structures that you can see, and so it just shows us how important it is to get that pressure and volume of blood going through the whole body. You need a big muscle to do that. Okay, so if I am looking at the left ventricle, looking at the front, I see where the blood is going to move out. Okay, and we'll talk about that first. And what I can do is I can stick my dissection probe in, and then it should come out right there. We have something that looks like this. So it's going in this structure from the left ventricle, moving out and coming out the top. So that tells me that this hole, this vein right here, is the aorta. So this is the aorta, and that's where blood will exit the left ventricle and go to the rest of the body. Okay, above, before that, actually, we'll get there. I can stick my dissection probe in here, and there's a little pocket. This pocket is actually one of the valves. So this would be the aortic semilunar valve, and there's one pocket here, there's another pocket here on this side, and then the third one is up at the top. Okay, so I'll show you guys. So as blood is leaving the heart, when it backflows, blood fills these pockets up, these valves, and closes so that we don't have a backflow of blood. The other tissue that you see that's kind of floppy right here, this tissue is part of another valve. It's the valve between the atrium, so this cavity here, this space, and the ventricle, so we call it the atrioventricular valve, or AV valve. So these cords are attached to the valve, and they connect to the bottom side to papillary muscles. But these strings are called chordae tendineae. So they're really, really tough. And what their job is as the heart contracts, blood is forced through the aorta. And we don't want it to go backwards into the atrium again. And so these valves have really strong ropes on them to avoid the doors from blowing back in the opposite direction and getting that backflow of blood, which we talked about. We don't want that. If you've heard the term pulling at my heartstrings, right? So these are heartstrings. When your heart is beating fast, it's really like putting a lot of effort on those heartstrings. So when you see your crush, and it's just making your heart beat real fast, and yeah, anyways. So those are called chordae tendineae. So again, this is the atrioventricular valve, this tissue that I have here, and leaving the left ventricle out, this is the aorta, and here is part of the aortic semilunar valve. Okay, we'll stay on the left side as well. In the left atrium, blood has to come into the heart. Okay, the atrium is where blood enters the heart, on the left and on the right side. The ventricles are where blood leaves the heart, so we can kind of remember it that way. So blood enters the heart in the left side from pulmonary veins. So I just follow this through. Yeah, right there. Okay, so this where the probe is coming through there, and there should be another one. Another one. Looks like they've been damaged a little bit. But yeah, so there are two. So two holes. These holes are the pulmonary veins. Okay, so that's how blood is entering on the left side of the heart and how blood is leaving on the left side of the heart. So my finger is now in the right atrium. Okay, the right atrium has passageways called the vena cava, specifically the superior vena cava. If I were to probe around towards the bottom, the probe would also come out here, and here is the inferior vena cava. What also is a little more challenging to see, and since we want to see, we'll dissect a little bit away so that we can have a better view of the next structure. Okay, the next structure that we want to identify is the right AV valve. The AV stands for atrioventricular valve. Okay, and the right AV valve is this kind of almost transparent tissue here. Let me see if we can get us a better view. Okay, so this tissue here is the right AV valve. So blood is now in the right ventricle. What I want to do is find where blood would leave the right ventricle. You see this vessel coming off is here. So here is again the other side of the right ventricle, and I'm going to find where this exits. This is the pulmonary artery. The pulmonary artery brings blood from the, so if this is closed, it's coming from the right ventricle out to the lungs. But yeah, that's honestly about it. So we have, just as a recap, all of the structures of the heart that we need to know. The interventricular sulcus, the one on the back points right to the apex, the one on the front runs parallel. You also have these parts, these tissues are auricles. Inside the auricle are the atria. This is all fatty tissue. This is the left ventricle, this large space here. This is the right ventricle, the left AV valve, and we'll open this, the right AV valve. This would be the left atrium. This is the right atrium. The aortic semi-lunar valve, which is here. Okay, these leading out to the aorta. And also if we come here, this would be the pulmonary semi-lunar valve leading to the pulmonary artery. Feeding blood to the right side of the heart are the vena cava. So there is the superior vena cava and the inferior vena cava. Feeding blood to the left atrium are the pulmonary veins here. We could follow this into the left atrium. Other things, chordae tendineae, those heartstrings, chordae tendineae, they prevent backflow. And the muscles to which they attach are called papillary muscles. So you see this bump right here, this is a papillary muscle. This is another papillary muscle. All right, so that is it. Heart dissection, pretty straightforward, pretty simple. Hope you enjoyed, and that's that. There you go.